Hello, I'm Hunter Hawke, and I'm a security solutions architect at Smallstep. Today, I'm going to show you how to use Certificate Manager and Step Issuer to issue TLS certificates to your Kubernetes Ingress controllers. For this video, I will be following my tutorial located under the Certificate Manager documentation on Smallstep's website called Securely Exposed Kubernetes Services Outside My Cluster. Before we start, make sure you have the Step CLI, Helm, and kubectl installed on your local client, and that you have a Kubernetes cluster in working condition. For this video, I've stood up a basic cluster on GCP's Kubernetes engine, but this tutorial will work for most configurations. Let's start by signing up for a Certificate Manager account and getting connected to a certificate authority. We're then going to install the open source Cert Manager project to add certificates and certificate issuers as resource types. And finally, we'll hook in Smallstep's open source Step Issuer project to help our cluster communicate with their certificate authority. So I'm going to start by heading over to smallstep.com and signing up for a Certificate Manager account. Let's see. Okay. Now I'm going to add an authority and call it demo. And for this project, I'm just going to keep mine with the free DevOps authority. Okay. So here's my new authority stood up. Here's my CA URL, the fingerprint. And if you don't already have Step installed, here's where you can install. So I'm going to bootstrap to the authority, which will allow my local client to talk to it and issue certificates. I'm going to pass in the context flag because I'm already bootstrapped to a couple authorities. This will keep it separate. Okay, so that's there. And the CA is showing as healthy. Okay, so now back to the guide. I'm going to begin by adding a new provisioner. This provisioner will be used for Step Issuer to talk to it to issue certificates. I'm just going to call it Step Issuer. It will stand up a JWK provisioner, which will require a password. Make sure you remember this, put it in a password manager, etc. I'm going to add myself as an admin on the provisioner as well, which will allow me to make changes to it. Okay. Cool. Now if I run Step CA provisioner list, it will show me all the provisioners, but I'm just interested in the Step Issuer one. And specifically, I'm looking for this key ID here. So I'm going to copy that and paste it somewhere. I'm going to remember that for later. Now that Certificate Manager is stood up, I'm going to go ahead and install Cert Manager into the cluster. Again, Cert Manager will add a couple different resource types. And as you can see, I already have these installed. But make sure you have those in your Helm. Then here I'm installing version 1.7.1 of Cert Manager into my cluster. Okay, there it goes. And now let's just make sure that our pods are running in the Cert Manager namespace. And as you can see, these three are all stood up and ready. So Cert Manager is taken care of. Now we're going to add Step Issuer. As you can see, I already have this installed, but make sure that you get these in and updated. Now I'm going to run the Helm install to install Step Issuer into its own namespace in the cluster. Okay. And now let's check on the state of those pods in the Step Issuer namespace. Those aren't quite ready yet, but they're standing each other up. Yep, and now we can see there's 2 pods ready. Okay, now that those are all in place, we just need to configure all the services to talk to each other. So I'm going to call step CA root. That's going to reach out and pull down the root certificate from our certificate authority. And I'm going to encode it in base64. Here that is. And you're going to want to copy that value and save that as well. Okay. So now locally, I'm going to create a file. I'm going to call issuer config.yaml. I'm just going to copy and paste this configuration here. Going in, replace the key ID with the key from our provisioner. And our CA bundle goes here. And finally, I need to update the URL of my authority, which you can find in your dashboard. No, this part. This file's been populated, so I'm going to save that. Yep, you can see that saved successfully. And now I'm going to go ahead and create a Kubernetes secret with the password to that provisioner that we just stood up. This will allow step issuer to go ahead and communicate with the provisioner we created earlier. I'm going to copy and paste this in. Actually, before I do that, I create the secret, I'm going to pass in a sensitive value, and to prevent it from leaking secrets into my command history, I'm going to go ahead and set hisControl equal ignore space and prepend the next command with a space. And what that's going to do, it's going to keep the password out of my history. So, title create secret in the step issuer namespace. It's going to be a generic secret called step issuer provisioner password. Here's where we set the password equals my awesome password. Okay, and I created the password, and it didn't save this value to my command history. Okay. So I'll clear that out. And now that that's been created, we can apply our config. That's been created. And now let's check on that property in the resource. Okay. Yep, that created correctly. Here you can see the CA bundle, provisioner KID, URL, and it's in the ready verified state, which means that step worked. So now step issuer is now able to begin signing certificates. So now we need to create a CSR, a certificate signing request. For this service, I'm going to call it internal.smallstep.com. And likewise, you can set up a password for this key. I'm going to use a different password. Make sure that you have it stored. That's been created. And now that we have the CSR, we can encode it in base64. Again, save this value for the next step. If you are curious, you can actually inspect that file. And see how that has been formatted. Okay, so I'm going to create certificate request.yaml. Paste this in. And I actually never saved this value from earlier. So let me go back and grab that real quick. I'm going to go ahead and paste it in on this line right here. Okay, and here you can actually set the duration of the certificate as well. For this use case, I'm going to keep mine to 24 hours. Okay. And then let's go ahead and apply that to the cluster. Okay, that's been created. And if we want to inspect that, here's all the information. We see the certificate here and the CA here. And here's my request. So now we're ready to start using this TLS certificate in the application. To use it, I'm going to go ahead and create a certificate.yaml resource. Again, paste this in. I'm going to call that backend smallstep.com because it's going to be created for backend.smallstep.com. And here again, we can set the duration of the certificate and we can set how often it renews. Right now, it's going to renew every 8 hours. Okay, there's nothing I need to do here to customize this because I'm happy with those settings. And let's apply the certificate YAML. And here we can inspect the resource. See that it's ready. Okay, so now that secret's been created. I'm going to go ahead and get that value out. And here we can see the CA certificate. This would be the root certificate, the TLS certificate that we have just issued, and here's the TLS key that corresponds with that certificate. If you're curious, you can go ahead and copy the certificate value. I'm going to echo that out. Step base64 decode it. And then step certificate inspect the results. Here we can see that is the root certificate from our new certificate authority. And if I do the same, oops, that's not what I want. I do the same for the TLS certificate. And I'm going to dash short that. And here's backend.smallstep.com. We also passed in a SAN for localhost. And the issuer shows us the demo intermediate certificate authority. So here's my certificate. It will renew every 8 hours. And all you have to do is hand this secret to your issuer, reference the certificate and key values from it, and you should be good to go.